Hello, good morning, good evening, good afternoon, everyone, depending on where you're calling from. My name is Paul Buffa, and I'm really excited to be teaching the third part of our SQL course today. Hopefully everyone's doing great. They can hear and see me. I'll just keep a look at the chat in case there's any I can't hear or see you. But hopefully that means everything's going smoothly. So for today, we are once again joined by our rockstar team. We have myself, Allison, and Wayne, who are helping out TAing the course with any questions that might come up or any logistical issues you have. So feel free to ask in the chat if you have any questions. We also today, I believe, have captions. So I think some people were asking about captions before. Hopefully we have that now. You can also just kind of read along if you prefer that. And we also have, you'll see a link in the chat here for our community Slack channel. So if you have questions that you'd like to ask, there may be a little longer form, maybe don't work well for a chat message here, but something you want to write out a little bit more. The community Slack channel is a great place for that. So go check that out if you want to ask questions there as well. So we've covered a lot of stuff in this course already. So in just the first two sessions, we've covered a lot of different topics. So I've listed them out here. So in the first session, we just talked about what is SQL, databases, DuckDB, which is the SQL dialect we're using for this course, as well as the select statement. And then in this second part, we talked a lot about joins, left joins, and filtering using the where and having clauses. So we've got 2 more sessions left. And today we're going to spend that time talking about different types of common SQL functions. So there are lots and lots of SQL functions out there that make life a lot easier. And today we're going to talk about some of the most important ones that are going to really help you as you're learning SQL. So we're going to talk about specifically aggregation functions, case statements, text functions, and date functions. So, in the first two sessions, again, we talked a lot about different types of SQL clauses. So, a clause is different than a function. Clauses are these sort of higher level areas of SQL. So, we've got the select, the from, the group by, the join, the where, and having. And hopefully, by now, those clauses are familiar to you. So, the select is for pulling information. All of our select statement queries start off with a select clause. From is where we get our data from. So it's the tables, we list them out there. Group by is for when we're doing some aggregation by a value. So we list which value we're going to group by. Join is how we connect multiple tables together, right? That comes inside of our from clause. And then where and having are going to be our clauses for filtering, with having being a filtering clause that you use for computed values. So while there are only so many SQL clauses, there's only about a dozen. There are many different types of SQL functions, hundreds, and in some SQL dialects, maybe even thousands, that make working with SQL much easier. And again, today we're going to cover these kind of high level ones that are really important for working in SQL. So we've got aggregation functions. We've gone through a few of these already, and we'll talk about that in a bit. So count, sum, min, max, average. We're also going to talk about conditionals. So that's going to be like case statements. Coalesce and is null. Text functions that are really helpful. So in, like, substring, replace, concat, and then date functions. And we'll cover date trunc and date part. So why don't we jump right into aggregation functions? We have a lot today, so let's not waste another second. Aggregation functions, again, we talked about some of these before when we did grouping in, I believe, session 1, such as count, count distinct, sum, and average. So this is a function that's going to take one of the different column names from your tables, and it will, do this sort of aggregation for you. There are many more common aggregation functions you might want to use, such as min and max, which work the same way as our sum and count distinct. So we pretty much just swap out that function name. There's no other arguments that it takes, and then it'll just work for you. Many SQL dialects, including DuckDB, offer more aggregation functions that are statistical functions like median or mode, correlation, or standard deviation. Depending on the SQL dialect you might have more aggregation functions, but most of them have this. And DuckDB has a number of statistical functions that are pretty neat. So for this one, since these are kind of simple functions to master, we'll just jump right into the activity and start working with them. Since again, they're not too complex. So let's just walk through those. And again, if you have any questions, feel free to ask in the chat here, and we can walk through those. All right, so I'm going to switch now to this screen. I'm also going to move my little floating head down over here so I'm not in the way. Maybe make it a little smaller. There we go. All right. So again, like in previous courses, previous sessions, we have this notebook here. I'll just put the link in the chat here as well, so everyone can follow along. Now, if you'd like to fork this, it's a great way to save a copy of the work if you want to kind of type it in as I go through it, or if you just want to listen and follow along, that works great as well. Some people had issues before with loading in the data set, so I did try to do a little differently for today, so hopefully works better for you. Instead of importing the data from another notebook, I'm actually just recreating the database in each notebook with file attachments. So hopefully that works a lot better, and there's no kind of loading issues, which some people had before. So let's go into activity 1, and we're going to do some of these aggregation prompts. So again, fairly simple, fairly straightforward. And hopefully this is kind of repetitive now, right? We're going to kind of ingrain this muscle memory of how to write these SQL queries, because we did some of this in the first session. So we're going to talk about aggregation. We've got the first prompt, count the number of orders by state. So if you remember the pizzeria database that I've been working with, we can open it up over here in the database pane, look at that sort of schema overview. There's a number of tables in here. we made some for demo purposes and for training purposes. But for this one here, we want to count the number of orders by state. We're going to need the orders table, which has these different fields in here. So we've got, an ID, customer ID, store ID, a date, number of items that were ordered, and the total amount. And then we've got a stores table. So that has the store ID and a bunch of information about the store. So to count the number of orders by state, we're going to join these two tables together, the orders table and the stores table, to get the state name from stores and the number of orders from the orders table. So I'll start off my SQL query like I have this whole course with a select statement. So we're going to do select. And maybe for now, I'll just jump right into the from clause, and then we can specify what we're going to pull in the select. So we're going to join two tables together, the orders table and the stores table. Maybe I'll start off with stores. Select from stores, and we're going to join orders on stores ID equals orders store ID. And now we're going to get the stores state, and we'll do an aggregation to get the number of orders. So this one, the prompt is to count the number of orders. So we use a count function. And for this, we can just either do count star to count the number of rows tied to the number of tied to the states. That's going to work fine. Or we could be more explicit and say we want to count specifically the number of distinct order IDs, which is helpful if you're worried there's any duplication of rows in your query. You can be really explicit and say, I just want to count exactly the number of distinct IDs. So I'm going to do a count distinct. We'll do orders ID. Now, if I run this query, I will get an error message, right? And if anyone knows why, this error message will be pretty descriptive. We need to add in our group by, right? So we need to group by the store's state. So I'm going to add that after my from clause and my join logic here. So I'll do group by stores state. And there is the first prompt, a count of orders by state. Pretty simple. And again, hopefully pretty familiar to you now, given that we've covered some of this before in previous sessions. Does anyone remember another way I could do the group by here? So here I've explicitly added in the name of the column, so the state from the stores table. We could also use that shorthand, which is to group by one, which I run and runs the exact same results, which means I'm grouping by the first column in my select. So the first value here, the store state. Okay, so why don't we copy this query for the next prompt here, which again is fairly simple. So we're going to do sum the total revenue by state. So if I add this in, we can now maybe call this something. We'll call this as num orders. Now let's add in a different aggregation function. Let's do a sum. So we'll sum now the orders total. So total was the total cost of the order. And we'll call this as revenue. Now I've completed the second prompt, right? We've added in now the number of orders, the count distinct orders ID, and a sum of the orders total, which is going to be the revenue. So you can see for both count and sum, they work the exact same way for the most part. It just takes one argument, which is going to be the column that we're looking at. Count, we can add in this distinct. You could actually do a sum distinct as well. It just doesn't make much sense in this context here because we want to add all the revenue, and there's going to be records with, the same amount of revenue, the same total, since it's probably the same order. So it doesn't make as much sense here, but you can actually add that in if you like. All right, now the last one here, we're just going to go through the other common aggregation functions, and they're all going to work really the same way. So we're going to add in a min, max, average, mode, median for the number of items per order. So if I opened up that schema overview and looked at the orders table, there was a column for number of items. So if you ordered multiple things, multiple pizzas in your order, the number of items would be greater than one. So we can then run these different aggregation functions on that column to understand a little bit about the shape of the data. So the different extent, the min, max, the average, median, and mode. So I'm going to actually remove some of this join logic here since I don't need stores now. I just need orders. And I actually don't think I'm grouping by anything. I'm just looking at the summary stats. It's just the min, max, average, mode, median for all orders, not for any subset of the data. So I'm going to just take out the stores state here. And then we could do, let's see here. Maybe I'll just swap this out with the min, and we'll add in here the orders and items. Min items. And just copy and paste this a few times for the other variations. So we'll do the max. Do max items. A few times. Have the average, median, mode. Average, median, and mode. There we go. So now we've got these summary stats for the number of items that are ordered. So the minimum number, which makes sense, would be 1. You can't order less than 1 item in an order. It wouldn't be an order. The max was 8. The average is 1.4. The median is 1. And the mode is also 1. So most people order 1. On average, they order a little bit over 1. And some people order a lot more. They order 8. So you can see for all of these functions here, again, they operate the same way. Pretty simple to use. And if you see aggregation functions, most are going to operate this way. Just going to check if there's any questions so far, but hopefully this is very familiar territory. All right, so now let's get into some stuff that might not be so familiar, something that might be a little new to you, which is going to be, here, let me get my slides back, conditionals. So we haven't covered this yet so far in the course, so this will be some new material. And you only move move the wrong one. Here we go. Move this up here. So say you want to apply some logic to your data to better suit your analysis. Conditional statements are going to be a great way to do that. So you might have some raw value in your data set, but you want to modify it for your analysis, right? So you might have something like, the category for your different types of items, and you want to group that and bin that in some way. Conditional statements are going to help you do that. So the most fundamental conditional statement in SQL that's been around since the beginning is the case statement. The case statement is sort of the classic conditional statement and how it's employed in SQL. So if you've used other programming languages, it's sort of like an if-then conditional. To start off a case statement, we're going to write out case. And then we're going to lay out a condition and a result. So you'll see here the way it's written is you write case. When is your first condition? So you write out a condition there. And a condition is going to be something where you're determining whether it's true or false. So you can say something like condition when the pizza name is a Hawaiian pizza, then you give an answer. So you have a result. So if that condition is true, then you could say something like, is delicious, right? Because Hawaiian pizzas are delicious. And you can keep doing this, right? You don't have to do it for one condition. You can have multiple conditions here. So here's another condition that you could add after your first one and have another result. So you could have, as many as you want. You may not want to have too many. It could be really complex, confusing conditional logic. But you can just lay out each of these conditions, each result. And then you could also have sort of a catch-all, which is saying if none of these conditions are true, then do this. So I'll use the else expression here. So that'll come after your conditions. So you first want to have the conditions then laid out, and then you have your else. It's important to note too, there is an importance to the order of your conditions, right? So if your first condition is complete, it's satisfied by this row, then it's going to go to that first result. If the second condition is also true, it won't actually be evaluated if the first one is true, right? So if you say something where like, A is greater than 1 as your first condition and A is greater than 2 as your second condition, and if A equals 3, then it's going to be satisfied in that first condition, and it won't actually hit the second condition there. So it's important to note that ordering does matter here. And then finally, after you've written down your conditions, and if you prefer, you don't actually have to write an else statement. That's an optional statement to do the catch-all. You have to just end the case statement. So you write an end, and then typically you want to add some name to this case statement. So you can add in an alias, which I just wrote as my first case one. Another common conditional that you'd use a lot in SQL is ways of handling null values. So we talked a little bit in the last session about joins and left joins. And when you use a left join, you might have some null values, right? Because a left join allows situations where there's not a perfect match between two tables. So you might have a null value for the table that you left join to. There's specific functions that you can use to handle for that. So while you could use that case statement I went through before and say, if this column is null, then do this, there's sort of a shorthand expression called Coalesce that allows you to do that without having to write out the whole conditional statement, the whole case statement. So for Coalesce, it works pretty simply. What you're going to write is the Coalesce function, and then that condition, so something where like a value is null, and then you're going to do this. So, the coalesce could be, if this column is null, we're going to do this. And to note, if the condition is not null, it'll return that value. So it's a good way to handle for null values. If you just say like, oh, if it's null, I want to classify this as maybe other, you can use coalesce and not have to write out the whole case statement for handling that. So why don't we do some activities for this, and hopefully that'll solidify what we just walked through and make that a little clearer. So here we are, activity 2 for conditional statements. So here's a fairly simple one we could do, which is to write a case statement that counts the number of products in the buckets of classic and non-classic. So if we open up, again, the schema here, and we go to the products table, there's a category for the various types of pizza products. So there's 3 categories in the data set. There's classic, vegetarian, and specialty. So what we're going to do here is, and we've done this before, is counting the number of orders, counting the number of products by each of these different categories. We're going to now put these categories into buckets of classic and non-classic. So here, let's just write out the simple query for counting products by category. So we'll do a select. We'll do it from the products table. Do a select star to get a quick look at what's in that table. Here we go. So we can see there's only 36 rows. It's a pretty small table. We have the name, the price, and then the category here. You can see at the top, there's 3 types of categories: classic, specialty, and vegetarian. So I could do category, count number of records as number of products, since it's the products table. And we're going to group by the first column there, that category. You can see for classic, there are 16 products. For vegetarian, there's 8. And for specialty, there's 12. So now we're going to add in that case statement to bucket these different types of categories into classic and non-classic. So we'll have classic stay the same, hopefully, with 16 results. But then we're going to bucket these 2 together, so there hopefully will be 20. So to do our case statement, again, we're going to start off by writing case. And actually, I can do it lowercase here. Doesn't really matter. It's not case sensitive. So case when category equals classic. So again, in SQL, to evaluate the value of something, you use just one equal sign. That's different than other programming languages where you might use 2 or 3. So case when category is classic, then we'll just call it classic. Keep it the same, basically. Now, we could write out the situation for a vegetarian specialty, or since we know there's only 3, we could just use the else, right, as the catch-all. So else, when category is not classic, we're going to call it classic. And then to complete our case statement, we're going to use the end expression, and we'll call this something. So we'll call it as. Okay. I'm going to run this query. You can see it correctly bucketed the non-classic categories together. You can see there's 20 products there, and classic is still the same with 16. So this is the same as if I wrote out, if I wanted to, I could have written out category equals vegetarian, food as non-classic, right? It's the exact same result here. I could write out each statement for each situation. But again, since I know it's just basically saying if it's classic, keep it as classic. If it's not, it's non-classic. Just having one condition and then a catch-all else statement works just as well. I also want to note how convenient it is to write this shorthand for the group by, right? So I could have in my group by included this case when statement, right? I'm actually grouping by this case when statement. See, if I actually put in here just the category, see what happens? So it's grouping by category. And since there's 3 categories, it's going to group by each of them and give me 3 results. So there's 3 results, but it's not aggregating by this conditional statement. It's not aggregating by the bucket. So you'll see that there's now 2 rows, one for a classic, and then 2 rows for non-classic, but it's not summing them together. So I want to aggregate by this case statement. So I could either just copy and paste the whole case statement and put that in my group by, which will work fine. Or if I use that shorthand, I don't have to write all that out. So that's why I do like the shorthand, just saying group by one. I find that it's a little bit faster. Oh, looks like there's a few questions here in the chat. Let me just pull those up. So here's the first one. What is the end as bucket statement? So to end my conditional statement, I have to write in end. If I don't, it will give me an error message. So let's say syntax error right here. It's confused. It's just like, think of it as like the closing parentheses, right, to your function. So you have to add an end there. Go. To close that off. And then, you typically want to name your column something. You don't actually need this, right? If I take off the alias as bucket, I'm just calling this column bucket. It'll just give it this really hideous name, which is the full case statement up there. So if I want to make it a little bit more readable, I just use an alias. So I'll say as and my alias, right? Whatever I want to write in there. Looks like someone's getting an error message there. Little hard to recreate. Hard to see. It's saying getting an error when you write the select case when. That may be a good question for the Slack channel. Maybe one of the TAs, Allison or Wayne, can help out with that. Looks like another question here. Why is the case statement alias, I'll just pull it up, need to be in quotes? You don't need to put it in quotes. Specifically, if it's just one word, you don't need to put it in quotes. So if I just wrote this again as bucket, I could leave it without quotes. It's going to work just fine. You usually use quotes if you want to have more than one word. So you can say my bucket, right? That works. If I didn't have this in quotes and I wrote it out like that, it's going to give me an error message, syntax error, because it's like treating it like, oh, you're writing a new phrase now. So common practice to put it in quotes when you use an alias, but you don't need to. Great questions. And please ask more if you've got any more. Happy to go through it. Okay, let's keep doing this a little bit more. So we're going to do some more bucketing using a case statement. For this prompt, the prompt is bucket orders by the number of items into the following buckets and count their revenue. So when someone orders 1 item, 2 and 3 items, or 4 plus items. So those are going to be the buckets that we make. So remember in the orders table, there's an N items column. We're going to use that. So I'm going to pull from the orders table. And we're going to, since we're bucketing items and counting their revenue, we're definitely going to have a group by. And then let's do that case statement for the number of items. So in case when, we're going to say, again, it's called N items is equal to 1, then we'll call it 1 item. Then when N items is 2 or I believe we went through or in the last session. So it's a way to do, another type of logical operator. So you can say when either of these conditions are true. So when n items is 2 or n items is 3, we'll say 2 to 3 items. And then the last one here, we can say when n is greater than 3, it'll be 4 plus items. And to close off our case statement, we'll do an end as, we'll call it again, bucket. Group by that first column there. Oh, forgot to add in what we're aggregating by. Here we go. So we're going to do, I think it's the sum of the total, which will be revenue. There we go. Now we've got sum of revenue based on a case statement for the number of items. Now, a few things I just want to note here. One, a little bit about formatting. So we mentioned before, formatting is not, necessary for a SQL query. It won't give you an error message if it's poorly formatted, but it is a good practice to do because it's going to make your queries easier to read and share with others. So you'll notice for this case statement, I try to line up the whens here. So it's really clear to see each condition that's happening, right? And when you break it out by lines like that, it makes it a lot easier. Often you might actually want to do another line for this, so you can see kind of when the logic ends. But definitely good practice. Another thing to note here is that, so you'll notice I actually used a single quote here, right? You're going to want to do that for creating strings in returning values. You only use this sort of double quote when you're doing an alias. So just notice it is formatted differently because it is treating a little differently. This is saying I want to treat this, I want to return a string value. So you're going to want to use that here versus using a double quote down here. Also to note, I mentioned before the order of logic here, right? So I could write this in a few different ways. I don't have to actually write it in this sort of like 1, 2, 3, right? So for example, I could say when n items is equal to 1, we'll keep that the same. That is 1. Another way I could write this is then saying when n items is greater than 3, it's 4 plus. And then if it's not one of those two situations, then it's got to be the 2 to 3 items. So I could say this is else 2 to 3 items. That's going to give me the exact same results. I just reran that query, and you can see it's the exact same. So if I had done this differently, though, so let's go back. Say I was like, all right, when n items is greater than 1, it's going to be 2 to 3 items. And then when n items is greater than 3, it's going to be 4 plus items. That 4 plus items will never happen, right? Because this condition is satisfied first. We never get to this condition where n items is greater than 3. So order does matter here, right? You got to be careful to see if one of your earlier conditions is maybe catching something that it didn't intend to. So a few different ways, again, you could write this to kind of get different results here. And yeah, it looks like there's some more questions coming in. Let me take a look here. So one question is when we write a conditional statement, is it necessary to add the group by at the end of the query? So you do not need to write a group by at the end of the query for a conditional statement. Yes, if there's no aggregation, that's right. So if we're aggregating by something, we're going to need to add that group by. We do not need it otherwise. So for example, I could just pull in all the raw data from this orders table. Let me just limit it to the top 100 just so I don't pull too much data because it's a really big table. If I run this, I have my case statement here that buckets the number of items, then I have just the raw data alongside. And this actually is a good practice to do, sometimes when you want to just check to make sure your case statement is working right. So, to make this easier, I'll just pull in n items alongside the bucketed. So I can see that the bucketing is working correctly, right? I can look at the number of items. All right, this was 1, so it bucketed that correctly. This was 2. I can check that, making sure the 4s are bucketed correctly. So again, you don't need the group by unless you're aggregating by something. Great question. Another question here. Can I leave the end as without a statement? So I'm not sure exactly what you're asking there. Do you need to write this as at the end? You don't need to write this. Again, that's just a way of doing an alias. So if you take that out, this query will still run. It will just give you kind of a less readable column title in your results. But you always do need that end when you're writing a case when. That's how you're telling this statement, I'm done with my logic, and I'm ready to move on to the next part. Let me just put this back so in case anybody wants this correct answer for the prompt. All right, now we've got one more here. So we're going to left join to Nevada stores, and when Nevada stores is null, we'll call it non-Nevada stores. So I think we also just, I forgot to add it in here. We're going to count. So left join to Nevada stores, count the number of orders, then handle for this statement. So we talked a little bit before about that special conditional statement for handling null values, the coalesce function. So we're going to use that here to handle for the situation where stores is null. So let's do here. So we'll do select from orders. We're going to join to the Nevada stores table on the orders store ID equals Nevada stores. And then for now, I'll just do the Nevada stores state. We'll count distinct orders ID as num orders. And for aggregating by something, we're going to enter a group by the first column there. Oh, forgot to add in. That was a weird error message. Not very intuitive, but I can just see I forgot to add in the ID for my join logic there. Okay, so first part, this is just with a normal join, not a left join. I can see the number of orders for all the Nevada stores. So a left join, just do that. You can see I now have two situations where the state is Nevada and the state is null. So what we're going to do here is we're just going to try to handle for this. So say we don't want the results to show null. We want to say a non-Nevada store, right? Kind of a maybe uncommon situation. I don't know why you would want to do that, but just for, again, teaching purposes, pretty simple. So we're going to add in this coalesce function. So for this, it's going to take the first argument to see if something is null. So here, we're going to just put it in the Nevada stores.state because there's situations where it is null. And then we'll just handle for that. So we'll say non-Nevada store or just non-Nevada. And we'll call this as, again, bucket. You can call this whatever you like. I'm just using the term bucket. Now when I run this query, it's now going to handle for that null situation and call it non-Nevada. So this is the same as if I wrote out, again, that case statement. So I could have done case when Nevada stores is null, and we'll call it non-Nevada, else Nevada, and as case bucket. Call that. Oh, I'm gonna add that to my group by. So you can see the exact same thing if I used coalesce or the case statement. It's just that this is a lot more concise, right? It's a lot easier to read and write out. This, can get pretty long if you want to write out all the logic for it. So it's nice. It's a nice little shorthand for handling that statement. All right, that's what I wanted to cover for conditionals. Just want to check if there's any more questions before we get on to the next set of functions, which are going to be text functions. All right, hopefully everyone's feeling good about conditionals. So why don't we jump into text functions? So, we've talked a little bit about the different types of data in, a SQL database, the variable types. So we've had numerical values, we've had date values, we've got string values. Each of them kind of have their own quirks and ways you can handle them. You can't treat strings like you would treat numbers, right? You can add two numbers together, but you can't really add two strings in the same way. So there's lots of specific functions for the types of data that's in your database. Text functions, again, have different functions than for numerical functions or date functions that are specific to just text. So we're going to walk through a few of those that are going to be pretty helpful. The first one I want to talk about, it's not actually specific to text, but it's often used with text, which is the in function. So it checks if whether a value is equal to an array of values. And again, you could use this with numbers or with dates, but you often see it used with text. So the way it works is you might have a condition, and here I just put in the string hello world. This could be a column that you're looking at from a table. And you want to check that the value is in this array of values. So if there's a match, the answer will be true. So here, actually, the first one, the answer is false because hello and world, even though each of those words is in that string, it has to be a perfect match. It has to look for that entire string. So this would return false. But if I added in the full string, hello world, that would be true, right? So even though the first two is not a perfect match, since one is a match here, so hello world, the answer will be true. So you might say, like, you've got a query where you're filtering by two categories, the classic and the vegetarian orders. You can use an in statement to handle for both of those rather than having to write out the logic, an or logic where it's like equal to this or that. You can use an in statement. Another way to check multiple string values is to use the like function. And this is a very, very common function in SQL. Really, really good one to know. So like how it's going to work is you're going to, again, just for example, I put in hello world, and I'm going to check if it's like this other phrase. So here it's a perfect match. So the answer is true, right? Hello world is like hello world. If I put in just the word hello, though, I would actually get false, which might seem confusing because it is like the other one. But when you just write it in a string like this, with nothing else, it is going to again check to see if it's a perfect match. So this will not be equal, but I can add in this little percent sign at the end, which says anything that comes after hello, that is totally fine. Let that be true. So as long as it starts off with hello, then let's make the statement true, and this will return true. That little percent sign, it's called the wildcard. And it allows you to match for just a part of a phrase and allow anything else in that phrase. So I could put this before and after the phrase. I could put this percent sign before. It would still be true. And that's helpful if I have, text that happens before the phrase I'm looking for. But it's a pretty good one to know because you might actually not exactly sure the exact match of the string. Part of the phrase, you can use a like function for that. Other common text functions that you'll be using often is concat, substring, and replace. So concat, that is short for concatenate. It's a way of just combining strings together. So you can see in the concat function, you just take a bunch of different strings and it'll literally just merge them into one. It used to be that you could only have 2 arguments in here, but now most SQL dialects allow you to have as many as you want. So you can see I have 3. I could be just 1. It can be as many as you like there. So it'll just concatenate all those strings into one new string. Substring is another one that's pretty common. It allows you to take part of a string out. So what you do is you first put in the string itself. So again, this could be a column name. Here I just wrote in hello world. And you specify the starting character. So it would be the first character here. And then the ending character, so the 5th character. So if I count the number of characters here, so 1, 2, 3, 4, 5, that'll just return hello. So you can see here the result is hello. The last one we'll cover before we go to the activity is the replace function. So it allows you to find a match in a string and replace it with another string. So this is similar to sort of the like function. It's going to look for that match within a string. It's okay. Oh, went too far. It's okay if there's stuff before and after. It's going to just try to find where that match is, and then it'll replace it with something else. So here I've said, look for the phrase world in my first string and replace it with SQL. And you can see the result is it's going to take out world and add in SQL. All right, so let's go into the activity to kind of reinforce what we just walked through. All right, so the first one here, actually mentioned this when I was talking about the in function, is to return all the products where the category is classic or specialty using in. So I'm going to, again, use that products table. So I'll select star from products. And now I'm going to add in a filter for classic or specialty. So for that, we'll use the where clause. And we're going to say category in this array of acceptable values. So the array of acceptable values is going to be classic, specialty. Now I get all those results, which is 28 rows, and you can see at the top here, there's only classic and specialty. If I comment this out, I ran everything. There's 36 rows for also the vegetarian products. Then my in statement will just filter for the 2 that I want. Now, this is going to be the logical equivalent of running out category equals classic or category equals specialty. Okay, returns 28 rows as well. But this is sort of a nicer, more concise way of writing this out. And certainly nicer when you've got maybe 20 values in here, right? Rather than have to write out 20 of these conditions, you can just put all those values in this array here, which is enclosed in parentheses, and just return those matches. All right, so that's the in function. Let's go through an example of how to use the like function. So for this one, return all the products where the ingredients include tomatoes. So there's a column here called ingredients. If I expand this a bit, we can read a little bit more. You can see for each of the product, there's many different types of ingredients, depending on what it is. So we want to do one where the ingredients have tomatoes in them. So, I could write out an in statement that says, well, whenever, I could write out each of these phrases here, but I just want to match for part of this string where it has the word tomato, right? So we're going to use a like function for that. So I'll select star again from the products table. And now for my where, I'm going to say where ingredients is like tomato. If I can spell it. Now, this is not going to work. It's going to return me nothing. If you remember, that is because there is text in each of these strings that comes after the word tomato. So I have to add in that wildcard, right? So if I do the % after tomato, and actually I could use a capitalized T there, that will be case sensitive. I now get 28 rows. So if I looked before, I think if I take this out, actually, there's 36 rows. So there's 8 products that don't have tomatoes in them. And if I add this in, I only get the ones that do. And I can just look through and see, yep, all of them have tomato sauce in them. Now, just to kind of highlight again that you can use that wildcard before and after, I could add this before here. Still the same results. I could also take out the T, right? And just omato. And it's going to be still the same results because, there's no other word that comes up as omato that's not tomato. Another cool part of like is you can add in just the phrase not before. So I could just pull up all the ones that are not like this matching string. And again, get those 8 rows for the pizzas that don't have tomato sauce, like they have barbecue sauce or buffalo sauce. So, a few variations of the like function using wildcards or using not. This can be really, really helpful in your analysis. Again, we're not sure the exact phrase, or it's like, part of a longer string. Often, I do a lot of the sort of reporting internally at Observable. We're looking at maybe specific UTMs, something like that, which might come up if you're an analyst. You might just want to look for a specific part of that phrase. So that can be really helpful because often UTMs might have a lot of information there. So just one use case that could be helpful. Oh, and I already did this one. So do the inverse. So yeah, we just did the not like. Okay, that's the inverse of like. Okay, so let's get through these last two before we get to the date functions and make sure we have enough time for that. So now we're going to use concatenate. So we're going to concatenate um, the pizza name with the size. So here, let's do again, we're going to select star from products. Go, here's all the products name. So this one, we're just going to concatenate this name with the size, which actually is the distinct product here, right? So there's a specific SKU number for each type of product, and each product has a specific name and a specific size to it. So let's do that. We're going to use the concat function, and we'll add in the name and then the size. And there we go. We've done that. And you can notice here, it's going to put it right at the end. So there's no space in between. We might want to add in a space to make that a little bit more readable. So we can add in a space like that. Now we've got the name with the size concatenated into one. Oh, looks like a question came up here. So how do you make the query non-case sensitive? So you could add I believe the function is lower, which if you want to lowercase all the text in that column, then you just treat it like it's all lowercase, or I think there's an upper function as well. So that's a way you can kind of handle for case sensitivity. But yeah, so concatenate, again, takes as many arguments as you like. I could add even more in here. It's really tasty. And that's going to keep working. I want to just note really quickly, not to get too caught up on this, but it can be helpful, especially if you're working in a place that has had very old SQL queries. There's another way of writing concat that was very popular for a long time. So you might pop up sometimes. So I'll write this as my first cat. This next one. So another way you can write this is using these this operator here. I don't know why the name is lost on me at the second. It's not called brackets, but the straight lines up and down. Sorry, I'm totally blanking out the name of it. But you can write it out this way. So you can basically use this operator as a shorthand for concatenate. As a second concat. Let's see if this works. Actually, I haven't tested this. Yep, it does work. Okay, cool. I was going to say, because it's kind of an older way of writing concatenate, which you just kind of use this shorthand. So if you see that, that's all that's doing. It's concatenating. The more common, newer practice is to write out the function concat. But this is a way you could have done it. The reason why this was used in the past is that concat used to only take two. Oh, it's the OR operator, the pipe. Yes, thank you. Totally blanked out on that. The pipe operator, it can be used as an OR in some programming languages. Here, it's a little shorthand for concat. Again, the reason why it was used is that concat used to only take two arguments in some of the older versions of SQL. So if you wanted to concatenate multiple things, more than two, people would write it out this way. But again, now that you can do that with the concat function, it's not really that necessary. All right, last prompt here, and just leave some time for the date functions. So we're going to just remove pizza in the name. So we're going to select star from products table again, and we're just going to do something that removes pizza within the name here. So we're going to use that replace function. They'll take in the name, and we're going to look for the phrase pizza, and we're just going to replace it with nothing. So I'm going to replace it with an empty string here as replaced name. There you go. Now I've got just that name here. I've taken out the word pizza. I could put any phrase in here. I could put in bread, right? I'll just replace pizza with bread. You can compare this to the original name. Pretty simple, but again, helpful functions to know. All right, take a quick look if there's any questions. If not, let's go on to the date functions. Perfect. So again, as I mentioned before, each type of variable in my database has different functions that are going to work with it. So numerical values, text values, string values, date values. So dates are very special types when you're working with data. If you've done analysis, you know that you can't treat dates like you treat other types. They're very unique in kind of this odd area of analysis. At least I think they're odd because they're kind of unwieldy sometimes when working with dates. But there's a number of date functions with SQL that's going to make working with dates a lot easier. So the three I want to walk through is date trunc, date part, and date diff. So date trunc, this is one I use all the time. It's really, really helpful. What it's going to do, it's going to truncate a date to a unit. So, for example, here I've got a date. It's June 2nd, 2023. If I want to just get the month out of that, so I want to return a date, date trunc will return a valid date. Um, if I want to get just like the abbreviated version for the month, I can use date trunc. I specify the unit I want to look at. So this could be month, week, quarter, year. Here I just put in the month. And then it's going to return me, again, a valid date that's just truncated to that month. Just to also note here, you might have seen this a few times. It comes up every now and then. This little double colon sign is a way of just quickly coercing a data type. So I wrote in the date here as a string, and then I just wanted to make it as a date type. So I just used that double colon sign for that. You will need that. Otherwise, it will return an error. If you try to use a date function with a string, it's not going to know how it's going to work. So you have to make sure you're using a date type. If ever it comes up and you see error messages around like, oh, doesn't know how to use a string or use an integer, that's usually why. So you just use that double colon sign and you specify the type that you're looking at. So date trunc is different than date part in that they both mostly do the same thing, except that date part does not return a valid date. So date part will just return that part of the date that I'm looking at. So again, I've put in the month here, and then instead of date trunc, which returned me a date, it just returns the number here, which is the month, which is June. So the former is kind of nicer if I'm like, say, I'm going to work with that result and visualize it, right? I want to visualize, monthly sales. I might actually want that valid date. Um, Otherwise, if I do it like this, I'm just getting a number, which, is a little bit harder sometimes to work with. Also to note, when I did the date trunc, notice it removed the information about the day, just went to the first, but it did keep the year. So when you truncate a date by a month or a week, it's going to take, remove only kind of the information sort of downstream from that unit. So, right, like month, if I'm looking at just the month, I don't care about the week or the day. So those kind of get truncated while the year is, above month. So that's going to stay in the results. So date trunc, date part, a way of extracting information from a date, different units from a date, while date trunc returns a valid date and date part does not. The last one here that's really helpful with dates is date diff. So that's a way of comparing two dates and getting the number of units. So for date diff, just like the first two ones, we first specify the interval we're looking at. So here we're going to try to find the difference of these two dates in months. And then you're going to add in the start date and end date. And again, order matters, right? If you do it the opposite way, it's going to return the opposite, so a negative value here. So here I have the start date as January 2nd, and then the end date as June 2nd. So it's going to compare those two and then figure out the number of months that are different, which is 5. All right, so let's hop into this activity in the last few minutes here. So first prompt is to count the number of orders by year. So we're going to select from the orders table. And to do this, we could use the date trunc or date part. But let's use the date trunc for now, just to demonstrate that. So we'll do date trunc, do it by year. We're going to use that order date. I believe it's just order date like that. And we'll call this as year, name. And then we can just count distinct orders E as num orders. We're going to group by that first column. Oh, here you go. So remember that error message I mentioned before that might happen? No function matches the given name and argument types. So it's saying date trunc, using strings. It needs to be treated like a date. So here I need to just do that little shorthand, coerce it as a date. And there we go. Now it's going to work fine. Order date is actually a timestamp, not a date. So it doesn't know how to use the date trunc function. So here I just changed it to a date on the fly. Now also note again, for the group by, I want to group by this truncated version of the date. If I group by the order date, I would actually be grouping by every date in there, right? So if I did that, I'm going to get way more than 3 rows. Get 1,096 rows for all the days that are in my data set. So I want to group by this whole truncated version of the date. So I could write out the whole bit here, the whole function, which returns, what I had before, or I can just do that group by one, the shorthand. You could also order by that first column, so you can see in the correct order there. All right, so let's do real quick in the last minute here, and then, maybe I'll save these last two if you like to do this on your own. I'm happy to share out the answers later. I think we're just going to run out of time. So let's do count the number of orders by day of week. So let's use the date part. And to get day of week, we're going to just write out day of week. Call this day of week. Day of week, make it a little more readable. And if I run this, I'm now going to get it by the day of week, which it returns it again as a numerical value. So if you want, you can convert this to a string. That was the next part here. You just be adding basically a case statement to say something where, like if day of week is 0, then write out Sunday. If it's 1, write out Monday, et cetera, et cetera. All right. Any questions around date functions? Perfect. So that was what I wanted to walk through for today. Just a note at the bottom here, there's little wrap-up questions if you want to do those. Hopefully they're not too difficult and it can kind of help you test your knowledge from the session today. So again, what we learned today, we went through lots of different functions. We just did a quick overview of some of the aggregation functions. We then walked through conditionals, text functions, and date functions. So tomorrow is our last session. So we've got one more tomorrow at the same time. And tomorrow we're going to get to advanced SQL. It's going to be a little bit tough. I'm going to warn you. Today was, I think, not too difficult, but tomorrow's will be a little difficult. We're going to talk about window functions, which is a really powerful area of SQL, but can be complicated. We're also going to talk about with statements, which are a personal favorite of mine. And we're going to just quickly cover a little bit about query optimization and SQL dialects. Lastly, we'll talk about the course assignment. So if you want to get a certificate in the course, you have to complete the course assignment. So I'll walk through what that is. Hopefully not too difficult. And then, we'll wrap up for the session. So we are at time. I want to be conscious of that. I know everyone's very busy. So thank you so much for joining today. I look forward to seeing you tomorrow. And again, if you have any questions, feel free to ask in the chat here or in the Slack community channel. So thank you again. Have a great day and see you tomorrow.